For the following, find the real zeros of f and use the real zeros to factor f. And we have f of x equals 2x cubed minus 4x squared minus 14x plus 28. So usually I start by trying to factor to see if I'm able to factor the polynomial. It doesn't always work, but I'll try to group. I'll group two terms at a time together. So if I group the first set, it has a factor of greatest common factor of 2x squared, and I'd be left with x minus 2. And the second group has a common factor of 7. I'll factor out a negative 7, and I'll be left with x minus 2. Because what's in these parentheses match each other, this method is working. It's called grouping, and I can factor out an x minus 2 from both terms, and I'd be left with 2x squared minus 7. I actually made a mistake here, so let me go ahead and correct it. I said there was a common factor of 7, but actually 14 goes into both of those. I was just sort of trying to go too fast, so let me correct that. So there's actually a factor of 14 that goes into both of those. I'll factor out a negative 14, and I would be left with x minus 2. So that would give me x minus 2 times 2x squared minus 14. And I would factor some more. I have a common factor of 2 in that second parenthesis, so I factor that out and get x squared minus 14. And it looks like this cannot be factored, this x squared minus 14. But, oops, sorry, I made another mistake. If I factor a 2 out, that becomes a 7. So this would be a 7. So it kind of looks like it doesn't factor, but it does factor if you allow radicals in your factorization. So it's a difference of squares, and it would factor to be x minus square root of 7 times x plus square root of 7. If you weren't sure about that, you could set that factor equal to 0, x squared minus 7 equals 0. Add 7 to both sides, that's x squared equals 7. Square root both sides, and you get x equals plus and minus square root of 7. So those are the factors, or those are the zeros which can create the factors for you from that portion. So we have a factor of x minus 2 and a 0 of 2. We have a factor of x minus square root of 7, and that's a 0 of square root of 7. A factor of x plus square root of 7, and that gives a 0, which is negative square root of 7. So we've got 3 zeros of this polynomial, and in factored form, that's 2 times x minus 2 times x minus square root of 7 times x plus square root of 7. So just want to pause here on this for a second, because the reason why this might seem a little bit confusing to you is in the past, if we were trying to factor, we would never put radicals in our factorization. So we have different levels of factoring. we can factor over the integers. We can factor over the rationals. We can factor over the real numbers, and we can factor over the complex numbers. And all of this is just how far you go with your factorization. So in the classes that we've had before this, you typically stop at this level, where all of the coefficients and the constants that you use in your factorization are going to be rational numbers. And in some cases, we kind of think of it over the integers. We don't even really allow fractions in there. So we're saying that we're going to go even further and allow for there to be square roots in our problems. And then in 5.3, we start even allowing complex numbers to be in our factorization. So I'm going to take another approach on solving this problem. So instead of taking the route of factoring, I'm going to use the theorems that we talk about to identify the real zeros. So the first thing that I would do would be to notice that there is a common factor of 2. I'm going to factor 2 out of the whole polynomial. I know I said I was going to avoid factoring, but this is going to make a lot fewer choices for us. So if I factor out a 2, I would have 2x squared minus 7x plus 14. So then what I would do would be to identify factors of p and q. So for p is going to be factors of 14 are constant, and q is going to be factors of 1, which is our leading coefficient. So for p, the factors of p are plus and minus 1, plus and minus 2, plus and minus 7, and plus and minus 14. And for q, the only factors are plus and minus 1. So then we're going to do p over q. And so we have 1 over 1, 2 over 1, 7 over 1, and 14 over 1. Plus and minus on all of these. And these are our potential rational zeros. So that's 1, 2, 7, and 14. Plus and minus of all of those. So we're going to use our calculator to identify if we have any rational zeros. So let's type in our y equals menu 2x cubed minus 4x squared minus 14x plus 28, and then we're already in ask mode. I'm going to go to my table and type in some of these potential rational zeros. So we've got 1, negative 1, 2, and negative 2, and it looks like I've identified one of my zeros as 2. Let's go ahead and do the rest. 7 and negative 7, 14 and negative 14. and that's the only one. So I've identified 2 as a 0 of our polynomial function. So now that I've identified 2, I'm going to reduce our polynomial by 2. So I'm going to use these coefficients, 1, -2, -7, and 14. Bring the first term down. Multiply. 2 times 1 is 2. We're going to add those together to get 4. 4 times 2 is 8. We're going to add those together to get 1. Okay, let me just pause here for a second because it's not working out properly. Okay, let me make my correction. I noticed that I should have been using a -2 here, so I'm missing this negative. So I brought the first term down to get 1, multiply to get +2, then I add to get 0. 2 times 0 is 0. -7 plus 0 is -7. 2 times -7 is -14. I get my remainder of 0. And I've reduced the polynomial down to being x squared minus 7. So now we started off with f of x equals 2x cubed minus 4x squared minus 14x plus 28. We factored out that 2 to get x cubed minus 2x squared minus 7x minus 14. And then I factored out x minus 2. Factoring out x minus 2 is what I did with this synthetic division here. And that left me with x squared minus 7. So then I could set x squared minus 7 equal to 0 to get my final 2 zeros. Square root both sides and get x equals plus or minus 7. So we've got our zeros of 2 square root of 7 and negative square root of 7. And we want to factor it completely. So this is not completely factored right now. We would factor that as 2 times x minus 2 times x minus square root of 7 times x plus square root of 7. Determine whether the following function is a polynomial function. If the function is a polynomial function, state its degree. If it's not, tell why. Write the polynomial in standard form, then identify the leading term and the constant term. So this particular function is a polynomial. What we want to focus in on is our variable and what power our variable is raised to. Here we have x to the first power and x to the third power. These are both non-negative integers, so we can say that this is a polynomial. So our powers need to be on this list of 0, 1, 2, 3, and so on, and they are. So this is a polynomial. To write it in standard form, we would want to write it in descending order. So we would want to write the highest power first, x cubed, and then the 5x. So that's the polynomial in standard form. The leading term would be that first term when it's written in standard form, so x cubed. And then the constant term, in this example, there is no constant term, so we say that it is 0. Determine whether the following function is a polynomial function. If the function is a polynomial function, state the degree. If it's not, tell why not. Write the polynomial in standard form, then identify the leading term and the constant term. So we have the function g of x equals 1 minus x squared over 2, and at first glance you might think that this is not a polynomial because of the fraction. But looking in the denominator of the fraction, we don't have a variable, so it can be a polynomial function. So I'm going to rewrite it in the standard form by breaking up this fraction. That would be 1/2 minus x squared over 2. And this can be written in descending order. So it would be negative x squared over 2 plus 1/2. And I think I'd also like to write this as negative 1/2 x squared plus 1/2. So that way we have a coefficient. Looking at the powers on our variable, we have a power of 2, and that is one of the allowed powers for polynomial functions. So this is a polynomial function. The degree of this polynomial function is 2, and the leading term would be negative 1/2 x squared, and the constant term would be 1/2. On this example, I forgot to mention the degree of this polynomial, and the degree of this polynomial would be 3. Thank you for checking out my videos. Have a great day.